Okay, here's a cute little problem. I always like these or things like this because it's just giving you some information, but it's not giving you the information you're used to, right? Usually they give you some particular function and they're asking you, well, find the antiderivative or find the derivative or whatever the heck you're supposed to do. In this case, they didn't tell you what f is. Okay? They're telling you two things about f. They're telling you the integral of f from 0 to 8 and the integral of f from 0 to 4, but they're not telling you what the integral, what f is. Okay? But you can think about this still as an area problem, and what you want to think about is, okay, if they don't tell me what f is, what else do I know about integrals? And what you do know about integrals is that you can break up the domain of integration, right? We know that if A is between B and C, then AC, you can break it up at B. This is very useful in a lot of ways. So this is how we can get these three things into play because we have integral from 0 to 8, integral from 0 to 4, and integral from 4 to 8. So we can write this down. Integral from 0 to 4 of f of x dx plus integral from 4 to 8 of f of x dx. We know that has to be the integral from 0 to 8 of f of x dx. I left this off, but if f is, of course, supposed to be an integrable function, so all this stuff should be defined. Now that looks weird the way I wrote it. Okay, let's put it there. Okay. So now what we're trying to solve for is 0 to 4. No, sorry, we're trying to solve for 4 to 8. We know 0 to 4. I can just put in what I know. This was -2. This is what we're trying to solve for. Whoa, 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 whoa. Sorry. Tell you. And this 0 to 8, what will we say 0 to 8? 0 to 8 was 12. Okay, so that just tells me that we don't have to worry about the next problem yet. We can just solve 4 to 8 of f of x dx is going to be 12 plus 2, which is 14. Okay. I have to work on my video skills a little more. This floating is terrible. All right. So these are always fun. And we'll see these kinds of things occasionally in this class where you're not necessarily given a specific function, but you may be given some things about it, and you have to use the rules that we've learned to figure out the answer. So a little bit more conceptual, maybe? I don't know. All right, so this is another problem in which that what we just said about breaking up the domain takes into account because this is a piecewise defined function. How do you integrate a piecewise defined function? Now, I'm just going to draw this so that it helps us see what's going on. Uh, oh, no, that was not right. I'm thinking here, 1, 2. So basically, we are integrating from -2 to 2 in the x. And this function is 2 over here. So that would be here. And then this is going to be 4 minus x squared. So it's going to be here. Oh, no. Well, we need one of those, so we'll just do it like this. That's what's supposed to be there. It was supposed to be defined everywhere. Sorry about that. I'm lost it a second there. So it's going to look something like this. Sorry, it's bad graph, but Let me see if I can make it a little bit prettier. Anyway, so if we're looking at what this question is asking me, it's asking me what's the area under the curve. And as you remember from your discussion of integrals, if there's a jump, discontinuity, it really doesn't make a difference because we can just talk about the area under here and plus the area under here. Now, if you had a problem where it was going off to infinity, that's a problem, that's a different situation. But this not going off to infinity, this is bounded. I can just break this up into two pieces. So you have your function is piecewise defined. It's defined a different part on a different domain, but that's okay. So what I'm saying is this is how you go about this. You break it up into the first part plus the second part. And then once you have it broken up, then you can put in what f of x is on each of those domains. Now, it's true that I put 0 here instead of there, and there's a 0 there. It doesn't really matter because it comes out in the wash when you do the integral, meaning that if you remember, our integral is a limit of a Riemann sum. And so that one point, as long as the thing isn't going off to infinity there, isn't going to make a real difference, right? Because what is the area under a point? We don't know anything about that, right? Okay, so here we have this, and now this is easy. When this is the hard part. Like the hard part was figuring out what we had to do, what property we had to use, but now both of these integrals are super simple. Right? So we're just going to do, this is going to be 2x. And then this is 4x minus x cubed over 3 from 0 to 2. So this is going to be 0 minus 2 is 4, which you can just see that, right, from the picture. Plus 8 minus 8 thirds minus 0 minus 0, right? So it's plus 4 here, plus 4 because it's minus minus. So let me write that a little bit more carefully because I know we're still learning this stuff. So it's 0 minus 2 times negative 2. So that's how it became plus 4. Because we evaluate at the top minus the bottom, right? So what I really mean here is 4 plus 8 minus 8 thirds. So this is 12 minus 8 thirds. So 36 minus 8, which gives us 28. Did I right? I think. Okay. Very nice.